Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of differentiability. This is the continuation of the concept of continuity and differentiability. So first we understood the concept of limits and then we linked that concept to continuity, and now we have this concept of differentiability. Now when do you say a function f of x is differentiable? You are able to differentiate that function. That is the meaning of the word differentiable. Alright. So, it is the ability to get the differentiation or the derivative of a function. Now, just understand the method of finding whether a function is differentiable or not. So, a function f of x is said to be differentiable at a given point x is equal to a if its left hand derivative and the right hand derivative at the point x is equal to a exist and are equal. So, you must have the left hand derivative and right hand derivative which should exist, and that must be equal. Alright. So, if this does not exist, if you get derivative, you are not able to find the limit of this. Okay. If the limit does not exist, you have those situations. We have dealt in detail about those situations where we may get that the limit does not exist. Okay. So, we have seen those cases and we have also seen in continuity that if left hand limit and right hand limits are not equal, then limit does not exist. Similarly, if the left hand derivative and the right hand derivative are not equal, then this derivative does not exist. As simple as that. This is also known as the first principle. You might have studied that in your first year board classes. Alright. So, you have found the derivatives of trigonometric functions, polynomials and logarithmic functions, exponentials, all using the first principle. So, that is the first principle I am talking about. Alright. So, when a derivative exists, only if left hand derivative and right hand derivatives are equal, and both must exist obviously. Alright. Now, what is the left hand derivative? Limit h tends to 0 minus f of a plus h minus f of a divided by h. The same formula, but 0 plus. Alright. So, when you move towards 0 from right hand side and move towards 0 from left hand side, both should meet at the same point. You must have the limits equal, then only the derivative exists. Alright. Now, let us say the derivative exists. Now, what about the relationship between continuity and differentiability? When do you say a function is continuous? If it is differentiable. Alright. So, if a real valued function f of x is differentiable at any point, a given point a, let us say, okay, at the point a, then that is necessarily continuous at that point. Alright. So, obviously, it will be continuous at a. But what about the converse? What do you mean by the converse? Alright. So, if a function is continuous at a, then can you say that the function is differentiable at a? No, you cannot say that. It need not be true. It may be true in some cases, but need not be true always. Okay. It does not hold for every function. If a function is continuous, it does not necessarily mean that it is differentiable. For example, the modulus function. Alright. So, you have studied that theorem, correct? Okay. Every function, every differentiable function is continuous. Okay, that is the theorem you have studied, and you have studied the converse of it. What is the example you had taken? The modulus function. Alright. So, if you have f of x is equal to mod x, the graph of modulus of x is this V shaped, correct, and this is y axis and the x axis, this is the origin. Now, the function is continuous Is there any gap? There is no gap, right? So, a function can be drawn continuously. It is continuous everywhere. So, modulus function is a continuous function, but what about the the derivative? Is it differentiable? Does the derivative exist at every point? It does not exist at 0. You cannot draw a tangent there. If the curve is this, right? So, if you have y is equal to x square, then you get a parabola, right? So, if you have a parabola, it is differentiable. You can find the derivative of x square at every point. You can draw the tangent here. Okay, what is the meaning of derivative? It is the slope of the tangent at a given point, right? That you study in the application of derivatives. What is the application of derivative? You can find the rate of change of a quantity. You can find the slope of the tangent, right? Similarly, you can find the slope of the normal and so on. Okay, there are many other applications which you have learnt, but the main application that you would remember for this geometric meaning is the tangent. Can you draw the tangent here? Yes, you can draw the tangent at this point, all right, because this is not a sharp point. This is not a sharp point here. This is a curve you have, but this is a sharp point, right? So, if you have a V-shaped graph, this is a sharp point. You can't draw the tangent there. You can draw the tangent. That line itself is a tangent. You can draw the tangent here. You can draw the tangent everywhere. Okay, except at 0. You cannot draw the tangent at a sharp point. Even if the graph is like this, you cannot draw the tangent here. Okay, so only if you have a slope, you have a curve like this, then you can draw the tangent. All right. So, this is not differentiable. We can find the left hand derivative, right hand derivative. Okay, separately. You will not get left LHD and RHD equal. So, that means the modulus function is not differentiable at 0. What about continuous? Yes, it is continuous. So, if a function is continuous, it does not mean that it is differentiable. Modulus function is continuous at 0, but it is not differentiable at 0, right. So, that is about the first principle that we need to keep in mind. So, let us continue with the synopsis.
Don't forget to like our video and subscribe our YouTube channel for all the updates.